Hello and welcome to T2 Day 26 of Honors Precalculus. Today we're going to talk about series and summation. A series of numbers is the summation of the terms of a sequence of numbers. So we're going to take a sequence and add all the terms together. So if we have some sequence that starts with A1 and then A2 goes all the way up to AN, we're going to add them all together. So this thing reads, the sum of a sub k from k equals 1 to n, k is called the index of summation. So what does this mean? It means we're going to have a way of shorthand writing a sequence that we're going to add together, and then it's called a series. What does this mean? It means the index starts at 1 and it goes to 5. So when k is 1, 2 times 1 is 2. So this is equal to 2 times 1 plus 2 times 2 plus 2 times 3 plus 2 times 4 plus 2 times 5. You go all the way up to 5. And this number is A1. This is the second entry, this is the third, this is the fourth, and this is the fifth. And when we add them all together, it becomes a series. So what we're adding together is 2 plus 4 plus 6 plus 8 plus 10, and that gets us 30. If we do the same thing over here, you list it out, you're starting at 5. You don't necessarily have to start at 1. We're starting at 5 right here. So you square it first. So it's going to be 5 squared plus 6 squared plus 7 squared plus 8 squared. Yeah, it's a little bit bigger, and each of them gets a little bigger. And when you add these all together, you get 174. One key thing is list them out, list the terms out. So I listed out all 5, or in this case, all 4, 5, 6, 7, 8. And yes, you could have trig functions in here as well. And remember, all you do is list out the terms. It's not that bad. So again, this one starts at 0. So what's this one going to be? This one's going to be cosine of 0 plus cosine of 1 pi plus cosine of 2 pi. And you fill the rest out, and you get that. Now, you just have to remember all of these values. Cosine of 0 is 1, and then it's going to be minus 1, plus 1, minus 1, plus 1, minus 1, plus 1, and it comes out to be 1. That cancels, leaving you with just 1. It's kind of cool. Just list them all out. Yeah, you could have more, and it gets a little bit long here, but you get something similar here. But what's kind of cool is you can notice patterns here. This is going to be sine of 0 right here, and then you're going to have sine of pi, and then you're going to have sine of 2 pi, and it goes all the way up to sine of 12 pi, and it is long, but you'll notice that this is 0 plus 0 plus 0 all the way up to 0. So this whole thing sums to 0. Noticing patterns, which is the core element of math, is key here. Mainly because you don't want to have to do tons and tons and tons of additions. So in that way, let's look at this one. You might be a little intimidated because this one goes from 1 to 100. So what's going on here? Well, if you start listing these out, this is just 1 plus 2 plus 3 plus 4 all the way up to 100. And I don't want to sit there and add all those together. What we can do here is pair things up. If you do the first and last term, that's 1 and 100, that's going to be 101. 2 and that would be 99 is also 101. So you can pair them up and you end up with 50 pairs, sorry, slid a little bit. You end up with 50 pairs of 101, which just multiplies out to 5,050. So you look for patterns like that. What about this one? What's the pattern here? Well, the first thing you plug in is 1. 2 times 1 plus 3 is 5. And then you plug in 2. You do 4 plus 3 is 7, and then you plug in 3, and you get 6 plus 3 is 9. And when you do this out, oh, I don't want to do commas because it's a series, not a sequence. It's a series, not a sequence. This goes all the way up to the second to last term is 101, and then it's 103. When you pair these together, you get the first and last term again. It's an arithmetic sequence again, 108. And if you count out the pairs, you end up with 25 of these pairs right here, 7 and 101. They all sum to 108. This one is 108. So when you multiply that out, you get 2,700. So with arithmetic sequences where there's a constant difference, look at the first and last term and then count the number of pairs you can make. So what this means is that if you have an arithmetic sequence, you can actually use this right here, which is really cool, which is the first term plus, this is the definition of an arithmetic. This is the definition right here, where the nth term is the first term plus n minus 1 times the difference. So what you can do here is what we just found out was that this is just equal to n times the first term and the last term, but it's not just n in front, it was half of them. What I mean by that is right here we had 50 and right here we had 25, and that's half of this the number of terms. half of the number of terms. So half of the number of terms times the pairings that we were working before is the formula for the summation. So what that means is we can then use it to do this a little quickly here. So what's this going to be? This is going to be, if you listed out the terms, it's going to be 6. Then you get 8. And not commas. I do that comma thing, and you got to help me not do that. 6 plus 8 plus ... And it keeps on going all the way up to 122 and then 124. And when you pair these up and do the number of terms is going to be 60 times a half. That's the number of terms. That's the number of pairs you can get. And you're multiplying it by what the sum is. 124 plus 6 is 130. Similar, 8 and 122 is 130. So you end up with 3,900. Over here, it looks a little, this one looks different. And the first thing that you notice maybe when you list this out is this arithmetic? Can we use that same formula we used before? If you list out these terms, you notice that there isn't a constant difference. If you list out the terms, you start with plugging in 1, you end up with -2, and then you get 1, and then you get a half, and then you get a fourth, and then you get an eighth, and they're getting smaller, but there isn't a constant difference. Like the difference there is going to be +3, and the difference there is going to be like -3. So this is not arithmetic. So you can't use the same formula. This is actually a geometric series because there's a constant ratio, the ratio between the terms. What do you multiply to get to that? You multiply by the ratio is -1/2, -1/2, -1/2, -1/2. So there's a different formula we're going to use. Also, I don't really want to write out all 10 terms and add them together. So let's find out what that formula is going to be. And that formula, just to give you a preview, is going to be based around the first term, which is in this case -2, the ratio, which in this case is -1/2, and the number of terms. The number of terms here, how many terms are there? There's 1 to 11, so there are 11 terms. So we are going to have a formula that takes these three things, the first term, the ratio, and the number of terms, and gets us the sum. Here's what it looks like. First, you write out the general, this is the general geometric. You have your first term, and then how do you get to each next term? You multiply by r, you multiply by r, you multiply by r. And if there's n terms, the last power is actually going to be, it's important to n-1. What you then do is you multiply both sides by r and get a new line. So I'm just going to multiply both sides by r. So what I'm doing is I'm taking this whole thing and I'm multiplying it by r. So I have my original line and I'm multiplying everything by r. What do you end up in that case? Well, you end up with all of these r's going up by 1 power here. So you end up with this r sitting out here, but then this becomes a r, this becomes a 1, this becomes a 2, and then it goes all the way up to n-1, and then this goes up to just n right here. You add 1 to all the powers. We added 1 to all the powers. And what you then do is you subtract this line, you subtract that line from this original line. And look what happens here. If you subtract it, this cancels with this cancels, this cancels with the first, I did too many of them here. This is r, I gotta start this right here. So this is, excuse me. Go back here, this would be AR to the first, this is 2, and this is 3 right here. So what ends up happening is these cancel there, and they cancel all the way up. Like this cancels with this, it cancels with the one before. And what are you left with? You're just left with this first term here minus this one. If you subtract this line from the first line, what you end up with is, you end up with the first one minus the second, so you end up with 1 minus r times the summation of k equals 1 to n. So it's k equals 1 to n of, you get just a1 here, and then you end up with this one right here, a1 times r to the n right there. And what this ends up being is super cool because it means that you end up with being able to isolate the original thing right here. You divide by 1 minus r. And the 1 came from, there's an invisible 1 right here, and there's this r right here, that negative r. So what this means is that you end up with the summation of k equals 1 to n of a sub k is equal to, and you factor out the a sub 1 here, the first term times 1 minus r to the n all over 1 minus r. And remember what all those are. This is the a sub 1 is the first term, that's the number of terms, and that's the ratio right there. So you can plug all these in and get the sum of a finite geometric series. They go to n terms. So what that means here when we do these examples here is we try to figure out what's the first term. When you do the plug 1 in, you get 2 times 1 over 3 to the first, so you end up with 2/3. And then you do, look back at the formula here, you have 1 minus r to the n, so we need r. The r in this case, every time k goes up by 1, the r is 1/3, and n is the number of terms, so it's 1 to 4, so there's 4 terms. So we end up with 2/3. The sum is going to be 2/3 times 1 minus 1/3 to the 4th power, all over 1 minus 1/3. And yeah, this is just fractions, but when you do this, you end up with 79 over 81. This does converge. When you add these 4 terms together, you get 79 over 81. Here, what happens? The ratio here is 2. The first term, what's the first term? 2 to the first is 2. And the number of terms, well, it goes to infinity. So let's try this and see what happens here. You get 2 times 1 minus r, which is 2 to the infinity power over 1 minus 2. What happens here? This gets infinitely big, so this diverges. It gets infinitely big. The other way you can see this is just 2 plus 4 plus 8 plus 16. This is going to get infinitely big, so it blows up. Let's do another one that's infinite, but it converges. The first term here is just 1/2 to the first, which is 1/2. The ratio is 1/2, and the n term, it's going to infinity. So that first term again is going to be 1/2, 1 minus 1/2 to the infinity power over 1 minus the ratio, which is this. Here's the thing. This right here, 1/2 to the infinity power, this goes to 0. So this turns into 1/2 times 1, over 1/2. So this is actually just equal to 1. So what this means when you list it out, this is 1/2 plus a 4th plus an 8th plus a 16th, etc. This equals 1. It's pretty cool. So remember, to do these out, you find the first term, the ratio, and the number of terms, and then you use the a1, 1 minus r to the n, all over 1 minus r, and that gets you the sum. If you get a number, it means it converges, meaning it sums to a number. If it gets infinitely big or infinitely negative, it is going to diverge. So the last thing you need to practice is coming up with the formula for each of these. The formula for each of these, they might give you the series. You have to figure out what's going on here. This right here, you have to recognize these are powers of 3. That's 3 to the first, that's 3 squared, that's 3 cubed, but then it alternates sign right there. So if you wrote this out, you'd start at k equals 1 to n, and it would be the opposite of -3 to the k power. And then you would do the summation notation that we did before. Over here, when you do this one out, this one, you can play around with it. It takes practice. Like, you can call it something other than k. I equals 1 to n. It's going to be -1 to the I power, meaning it's flipping signs, negative, positive, negative, positive. And then it's going to be 2/3 to the I minus 1 power. You can play around with it to see where that comes from. And then you would use the summation notation, which is a1 times 1 minus r to the n, all over 1 minus r. You'd use that formula to find the sum. We'll definitely do a lot of practicing of this in class, especially this proof, but the big thing to walk away from are the different types and this formula right here for summation of a geometric series.